The assignment of IP addresses to client machines and to servers and other devices on the network has long been a challenge to administrators, and there's been a number of technologies come along to help get these IP addresses configured and assigned properly and reliably and efficiently on these various devices. And in this video that I've entitled IP Address Configuration Options, I want to talk to you about 3 options for IP address configuration on all your devices that you're going to see on the exam, and you just need to be familiar with these and understand how they work. The first one is manually configured IP addresses. This was the standard for a long time. Then there's BootP and DHCP. Now let's take a quick look at every one of these individually. First of all, the manually configured IP address is where we're actually going to go in on each machine and assign it a manually configured IP address. Now these are usually static addresses, meaning they never change. Now these have some very distinct advantages. It's the simplest option to implement. I don't have to set up any other service or technology. I don't have to worry about settings. I don't have to make sure that different things are still running on the server. It doesn't go down. It's fixed. It's predictable. Generally, I'm working with static IP addresses, so I know what address every device has. It doesn't change. The disadvantages are obviously high overhead. Somebody's got to physically go to each machine and set these things up. And then there's an even bigger one, and that's a risk of wasting addresses when devices are removed. Because if I have 100 servers and I give them all static IP addresses that I created, that I'm maintaining, say we have a pool of 300 addresses, and then one of those servers, we take it out of commission. If we don't remember to take that IP address and put it back into our pool of available addresses, we kind of burn through our addresses and we're wasting them. And obviously, reconfiguration of the machines is time consuming, can be complex, because if I've moved one machine to a different subnet, I have to manually change the IP address information. And so that really doesn't work in a large involvement. Now, keep in mind, the manual static IP address is still a favorite for things like servers, routers, and that sort of thing. But for general client machines, it just doesn't work a whole lot in the real world, nor on the exam. BootP is a second option. BootP is a server service that responds to a client computer. And when that client computer starts on the network, it broadcasts a BootP packet. And this will allow the server service or BootP that's running somewhere on a server on the network to assign an IP address to that client based on that client's MAC address. It just does a one-to-one match with that client's MAC address, and it gives it an IP address that we told it to put on there. Now, what are the advantages of BootP? Well, it's at least centralized. We're no longer manually going to every machine, and this was popular for a while. It's a widely supported protocol, again, because it's been out so long. And the fact that we can just set up a BootP server, do a little bit of administration. When the clients turn the machine on, they get an IP address, everybody's happy. This is supported on Windows, Unix, mainframe, all the things out there. It's hard to find an OS that does not support BootP. But it does have its disadvantages. You only get an IP address renewal on restart with a 30-day default lease. And you also have a risk of wasting addresses because there's no automatic reuse. I have to manually go in and set up my address pool. And then once I lose something based on MAC address, I have an IP address out there that's tied to a MAC address. And when it never sees that MAC address, it never assigns that IP anymore. And there are limited extensions because, as you know, we're not just giving the machine an IP address, we're also letting the machine know about DNS server locations, Win server locations, on, and BootP is limited in that respect. And that kind of brings us to the granddaddy here, and that is DHCP. Dynamic Host Control Protocol is what that means. And DHCP will automatically assign, renew, and maintain a pool of IP addresses. It's really neat what DHCP will do for you. It also gives you what's called reserve addresses that you can set up, and these reserved addresses will allow you to give a particular IP address to the same machine over and over and over based on MAC address. And it's very, very similar to a static although a lot of administrators still choose static, manually configured IPs for their servers. Now, for client machines, DHCP has a lot of advantages. First of all, it's reliable. It's been around a while. It also removes any risk of manual entry errors. When you're doing manual entry of these IP addresses, it's obviously very easy to fat finger those things, transpose a number, all those things, and it creates havoc on a network. DHCP will put them in correctly every time. It greatly reduces configuration and reconfiguration of addresses. So a mobile device whose location changes often gets a new IP address every time it's on the right subnet, it connects on the network. There's a large set of client configuration parameters called options, where we can also assign DNS server IP addresses and other addresses as well. The disadvantages of DHCP, it requires careful attention to security because someone can set up a rogue DHCP server and give themselves addresses. There's a point of failure risk. If this fails, you no longer assign IP addresses and people on the network start falling off. And it also requires additional support in routed networks to pass the packets around through the routers. And so that's kind of becomes a problem, but there's all kinds of services out there and programs to help you with that. So that's your main IP address configuration options. Just make sure you're familiar with these three. Make sure you understand the strengths and weaknesses of them, and you should be okay for the exam.